Hello, and welcome to Quantium Insights. Our mission is to empower organizations with data-driven strategies, advanced analytics, and innovative technology for real-world impact. Our expertise spans 6 key areas: predictive modeling and forecasting, spatial epidemiology and geostatistics, implementation science and program evaluation, monitoring and evaluation systems, data visualization and dashboards, and training and capacity building. We help transform complex data into actionable insights for better decisions and sustainable results. Dr. Amobi Onovo, founder and principal consultant of Quantium Insights, will provide a demo of the first prototype model, StrokeRisk AI, a personalized, explainable stroke risk screening tool for clinics and wellness programs.
Hello everyone, I am Dr. Amobi Onovo, and I'm excited to introduce StrokeRisk AI, a personalized, explainable stroke risk screening tool. This app combines clinical, demographic, and lifestyle data to estimate stroke risk probability. It's designed for clinics, wellness programs, and individuals who want proactive insights into stroke prevention. So I believe you have the URL already, or the link, which you can use to access the app, which is being deployed and running in real time on Hugging Face. So simply, when you access the web, you will, the first interface you see is this beautiful logo, which is my recently launched consultancy firm known as Quantium Insights. And then you simply just scroll down to access the user interface so you could start interacting with the app. So the whole essence of this demo is to provide high-level context so you could easily navigate this tool and essentially make predictions, and most importantly, understand how to make interpretations, meaningful interpretations, which we'll see. So at high level, this app is built leveraging one of the most robust, powerful machine learning algorithms known as extreme gradient boosting, and it's being trained roughly on about 10,000 healthcare individual level data at the facility, covering or spanning data set across demographic, clinical, and lifestyle. And essentially, the model develops internal probability essentially based on this input data that is being used to train the data, and then essentially establishes an output in terms of the risk level, whether the client is at risk of stroke or not at risk of stroke. And then importantly, which we'll see, I think that is one of the powerful use cases of this app, is what I call the explainability panel. I'll get to that shortly. So I think the app is very user-friendly and straightforward. So you will notice that across the components for demographic, clinical, and behavior, you will notice pre-filled data set already. So this is essentially, when I was building this app from ground up, was essentially to make it easier for users to see essentially the data input already. So it gives you an idea essentially on how to capture this information, right? So for demographic, just to quickly go through, you say we have age in years, gender, information on whether the client was ever married, and so it's a combination of both numeric and categorical variables. So categorical, for example, gender, you use this downward arrow where you see them, tells you that this is a categorical variable that you could easily select, right, and unpack the categorical class within that feature. For male, you could say ever married. If you click on this, it's a simple response on yes or no. Reasons type, you can see urban, rural. Work type, there's some classes here where the individuals working in the private setting, self-employed, doing a government job, maybe focus on taking care of the kids, or never worked, right? And then in terms of the clinical features, we have glucose level, we have BMI, we have hypertension, and this you can see hypertension and heart disease is a dichotomous data essentially with two categorical classes, yes or no, and they recorded accordingly. One for yes, essentially establishing that the outcome of interest is present here, in this case hypertension, or no, the individual did not or do not have hypertension, right? And same here with heart disease as well. So in terms of lifestyle, essentially the behavior, this their point of feature is tracking smoking status. As you can see, these are the categorical class here: never smoked, formerly smoked, or none. And then you can see how easy it is. You capture these informations, and then what do? You hit submit. And when you hit submit, this is the section. The area highlighted in light green is the verdict box, essentially, right? Provides you with that prediction level whether the individual, based on this input parameter, is at risk of stroke or not at risk of stroke. As I said, one of the interesting use case is the signal. I call it the signal. In data science, we'll refer to them as sharp interpretability. But for me, this section, you will see beyond just the risk level, and that's one of the powerful use cases of this app. It will provide the top contributing factors, like the top 5 contributing factors. And it doesn't just stop there, right? You'll notice the dialogue column known as effect. So this is essentially where you begin to see, unlike the AI black box, you will understand clearly how the AI behind the hood is making its prediction, right? And you can see not just this risk level, but understanding the why behind the predictions. And then, of course, you will see more additional use cases under this panel known as raw response. I will get to it quickly. So let's take this for a drive. So in terms of demographics, as I said, these are pre-filled data points. So let's take some examples quickly. So under demographic, let's say I'm going with a young individual. Let's say this individual is 19 years old. Gender, let's go with a female. You can see how I'm doing it. So imagine you're a healthcare worker sitting in front of this app and a client present. So this is essentially what you do, right? Or an individual who have access to this app could also use this as a screening tool as well. And then essentially, in this list as we go, in terms of ever married, let's say she says no. Residence type, yeah, we can still keep it at Auburn for now, for this example, right? So work type, based on these classes here, let's go with never worked. So in terms of clinical parameters, so for glucose level, let's go with, let's say probably for based on this example, maybe a relatively normal range. Let me use 90 for this demo, milligram per dl. And then for BMI, let's go with a also relatively normal range. I believe based on the CDC classification, I think normal BMI range is between 18.5 to 24.9, right? So maybe I go with 19.7. Yeah. And then in terms of the questions on hypertension and heart disease, let's just keep them as no, right? Behavioral lifestyle, she says she never smoked, right? And then we'll hit submit and we'll see what the results look like here. So we'll pre-fill this information, we hit submit, wait for the magic, boom, you see the classical prediction. And you can see the labeling here. The algorithm predicts based on these informations provided across demographic, clinical, and the lifestyle. You could see the individual here in terms of prediction is not at risk of stroke. And clearly, I think another interpretation just to help you, this based on the model generates probability, right, based on this input parameter. So when the individual is not at risk of stroke, this essentially means that the probability score for this client is less than the threshold we've set. And I think I'll explain that further. So you will see this was what I was referring to initially. The model not just provides the output level, but also unpacks what the top contributing factor. And you remember we have roughly 10 features here, right? So the model outputs the top 5 contributing factors, as you can see: age, BMI, average glucose level, gender, smoking, right? And then the beauty here, if you look at the effect, this is essentially where you could make additional, you have the power to make decision which is guided based on evidence, based on data. You can see how this provides that timely insights to, let's say, a healthcare professional or a public health professional in the field using this as a screening tool. So you will see, based on this data, just to give you some insight, if you look at age and BMI, and if you look at the effect, if you look at the arrows are pointing downwards, right? So what does this tell you? In this case, age and BMI, and also their glucose level, which is in this case healthy for this individual, is lower risk, right? So you are at lower risk of stroke based on this, based on age and BMI and the glucose level. So, but at the same time, when you look at gender, you see the arrow is pointing upwards, which provides insights that by virtue of being female, based on this data, that increases the risk of stroke. While in the other variables, it's those levels lowers the risk of stroke, right? And of course, you can see the smoking as well. Smoking status is the arrow is pointing downwards, right? Smoking levels for this client lowers the risk of stroke. So one other, I think I would say, powerful function again is you could look at the raw response. So I think one of the approaches I use is to demystify the whole AI black box, so you could see what's happening under the hood. And you don't necessarily need to be a biostatistics or a data scientist like me, but essentially, based on these signals, you could clearly make interpretations, right? So based on these values, let's just click, you can see the arrow here pointing on the raw response. So you see exactly how the rules behind how the AI or machine learning model is making its prediction, right? And when we select that, you can see clearly, as I said, in this case, you can see the risk level is 0, which aligns with the level above that the individual is not at risk of stroke. And then you can make that interpretation based on the risk probability. As I said, the risk probability will be lower, right, than the threshold we set. Now you can see the risk probability is roughly at 0, because it's 0.00027, which is very, very low compared to the threshold of roughly 38%, right? So, and I think one of the interesting things just to mention, beyond just these values you see, there is a form of ranking. So among these 5 variables and the signals using those indicator arrows we saw earlier above here, you will notice if you look at the results for those probability values for each of those features, you see they are negative. Negative in the sense meaning that they lower the risks based on this scoring, lowers the risks, right, in relation to the outcome of interest, here being the risk of stroke. So, and you will see gender, which the arrow was pointing upwards here, right? If you look at the probability value here for that feature, gender, you see is positive, right? And it's 0.24, which is essentially telling you, yeah, though overall, based on the results, right, the relationship, the learnings from the algorithm, this individual is not at risk, but there are some levels to believe that being female here, right, may increases the risk of stroke. So this helps with providing that decision point. If within the healthcare setting or within the public health practice setting, there are some form of essentially maybe gender-related interventions that may happen. And so these can be tailored accordingly in a client-centric manner, right? So I believe this provides some insights on how to make these interpretations. I think we can take one more quick example. So before we went to it, a younger individual, let's go with an older individual, let's say 78. Let's go with this hypothetical example. In your case, essentially, you could provide in the available appropriate data and make those contracts and comparisons and see how, play with it and see how those use cases and interpretations happen. In this previous example, we used female. Let's say this time around, let's go with male. You can see just an easy click. Question on ever married, previous individual was not. In this case, let's say yes. In terms of reasons type, okay, let's go with rural. The individual lives in a rural setting. Work type, previous client never worked. So in this case, let's say the individual works in a private firm. This is just simple examples, right? This is just hypothetical example. So clinical here, glucose level. Let's go with a very elevated glucose level. What am I thinking about? Let's do 260 milligram per dl. In terms of BMI, in this case, I'll go with a range that essentially, in terms of the CDC classification, overweight. I think overweight is essentially anything parameters above 39.5 or so. So yeah, so let me go with 41.4. So that this is a high BMI that puts the individual in a classification of obesity based on the CDC classification. So in terms of the other variables like hypertension, heart disease, let's say the individual is hypertensive, right? In terms of the report, set 1 here, and let's say the individual, in the past has or currently has a heart disease. Let's set this. So as I said, this is a typical example, and then in terms of smoking status, right? So previous individual or example we used was never smoked. So in this case, let's go with smokes. Right. So when we've done that, as I said, you just do what? You hit the button. But one thing I wanted to draw your attention to, remember this was the outcome results, right, of the previous example or previous client. So note that in the verdict box I talked about, which provides the risk level, not at risk of stroke, you see, note the color code is in light green, right? So let's hit, based on this example, let's hit submit and see what the output looks like. So in this case, you could see clearly the individual based on the input data and the prediction. This algorithm predicts the individual at risk of stroke, right? And you see the color code changed from light green to a light red, right? And then let's look at the interesting top contributing factors. You can see in this case we have age, we have glucose, BMI, work, and smoking. And when you look at the effect, you see all the arrows are pointing upwards. That means all these variables are contributing, right, to increase in the risk of stroke in this client. And to add to this reason, understanding the prediction and decision points, you could see, just like the typical example, use this arrow to unpack the necessary raw data. So you're seeing exactly under the hood how these predictions are happening. So you see, based on the risk probability, previous risk probability, as you see, was roughly 0. So in this case, you see 0.92, which is roughly at approximately 93% compared to the threshold. So you see, in this case, when the individual is at risk of stroke, the risk level is 1, meaning that the probability score for that individual is higher than the threshold. How easy is this to interpret, right? So, and then, as I mentioned earlier, see something interesting. So beyond just the risk factors, as I said, the top 5, it ranks them in order of importance. That's essentially the predictive power. So you see, in this case, just as this labeling age, glucose level, BMI through smoking, if you look at the probability values for these factors, so you can see age stands at 3.34. In that manner, you can see glucose level at 1.53. You see BMI 0.78, 45% roughly for work, 12, roughly 13% for smoking. So you see that order. And this helps essentially in the clinic setting or public health practice essentially, or when essentially you're making decisions in designing programs or tailoring the actual preventive care for this client. These are important informations to make, and essentially where you want to hone in on what matters, right? So I believe based on these insights, this transparency makes AI easy to understand and trustworthy. It doesn't just give a label for what we see, it shows why, right? So this StrokeRisk AI app is not a diagnostics tool, so please note that it's a support system that empowers clinicians and wellness programs to identify potential risks early and encourage preventive care. So this is just one example of how AI can transform health decision making. So I am thrilled to launch it as part of my consultancy, Quantium Insight. So, ladies and gentlemen, I think quick takeaways here essentially, you can see that this is an AI powered driven personalized tool, which the model adapts based on each user's data. So, and this essentially can be tailored within your context because, of course, the risk could vary from region to region. And essentially, as part of the services I do provide in Quantium Insight. So, for example, here you could see we are providing individual parameters and getting the risk prediction. So, let's say, for example, within the healthcare space or public health practice, you want to do, you have your electronic medical record or a tool that allows you to pull client level details. Let's say you're able to pull 5,000 records and you want to run predictions at the same time. That's very, very possible. We could essentially orchestrate this to integrate that parameter where essentially it is just an upload of your structured data, maybe in Excel format or in CSV, and you could just upload and hit that submit button. Essentially, it will take that data and run predictions and generate an output predictions for each individual client level records in a record time. So if that resonates with what you are looking for, do essentially you know how to reach out. My information is provided. Go to quantiuminsights.com and essentially reach out directly via my email or essentially book a consultancy, a strategic call, free 30-minute strategic call so that we can engage. And also to point out, and as I think clearly you can see based on the explainability panel, that unlike the black box AI, you can see the why behind the predictions. And also, just in case you're wondering, I think it's important to point out the threshold that we used here for this model, which we set at 38% roughly. This is essentially based on the data set that we used for developing this prototype. So we set this threshold of 0.38, roughly 38%, to prioritize sensitivity, making sure potential stroke cases are flagged for further confirmation. So in the healthcare space, it is safer to cast a wider net at the screening stage. This is in contrast, like sectors like banking, where priority for precision may be considered, where reducing false alarms is more important. So, and I'll wrap up by saying, so Quantium Insights is not just focused on the healthcare but other enterprises. So let's say, for example, you're in the financial sector and you want to build this real-time model integrated within your data pipeline, and you want to develop a model that essentially can forecast credit or liquidity risk. Do feel free to reach out. And also at the same time, maybe it could be customer analytics, right? Churn risks, you want to detect fraud. We'll build that for you at Quantium Insight. So look forward to your feedback and look forward to engaging and building these kind of tools essentially for global good. Thank you for listening.